Welcome to our second module. In this video, we're going to be looking at box plots. And these are one of the ways that we're going to look at how we can represent our data. So essentially a graph that we can use. So firstly, what is a box plot, or what does it look like? So here we have three different box plots, and they are representing our data, taking some important information and putting it on the page so that we can quickly see it. Now it doesn't contain all the information of our data, but it does represent it in a nice way. When we're talking about a box plot, we need to know some terminology. Now these are often called box and whisker plots by people because there's two whiskers out here and then we have the box on the middle. So just know if you see the terminology box plot or box and whisker plot, they're talking about exactly the same thing. Okay, so what is a box plot and what are the parts on here? So you'll see that there's 5 main sections here. And each of these represents something important about our data. The middle line is going to be our median. So the measure of center that we're using in our box plot is the median. So you can look at your box plot and straight away tell where the center of your data is going to be. Now, the value at the bottom and at the top are what we call the lower and upper extremes. Now these are the smallest value of data you have and the largest value of data. And then finally, these other sections are going to be our quartile 1 and quartile 3, which we looked at in the previous video. So if you've forgotten what they are, please go back, make sure, check your notes. You need to know what these things are. And remember, our median is also referred to as quartile 2. So a box plot is a way of quickly representing from our lowest value through to quartile 1, median, quartile 3, and then the largest value. Now it's helpful because it can show us a snapshot of the spread of our data and whether it is skewed to one side or not. So that's what a box plot is. Now in a box plot, we can use it very quickly to find the range and interquartile range. Because the interquartile range is just the difference of Q3 and Q1, whereas the range is the difference of the upper and lower extremes. So you can see it's very easy to find them on this way of graphing it, whereas it would take a lot longer on a histogram or any of the other representations we've looked at previously. So here we have an example of a question that we could be asked. We need to find the interquartile range of this data, or the data represented on the box plot. Now we should remember that interquartile range is quartile 3 minus quartile 1. So it's this value because this here is Q3 and this here is Q2. Q1. Okay, so we have Q3 and Q1. We can substitute those values in. So it's around 67 and 20. So we go 67 minus 20 gives us 47. And there is our interquartile range, found very easily from our box plot. Now it's your turn. Find the interquartile range of this box plot. Pause the video now, and then continue and fill in the quiz. Okay, so the interquartile range, again, we're going to use Q3 minus Q1. So Q3 minus Q1 is the interquartile range, and that's going to be about 50 minus 15. So our interquartile range is going to be 35. Don't worry if you were 1 or 2 off, that's completely fine. But that's how we find our interquartile range. Now we have a similar question to find the range. So we should know that the range is the maximum value minus the minimum value. So it's this one minus this one. So it's going to be 90 minus 9. So we get 81. So there's our range for this box plot. Your turn, try to find the range for this one. Okay, so again, range is max minus minimum, and it's going to be 95 minus 20. So we're going to get 75. Okay, making a box plot. So when we're talking about box plot, another important term that comes up that we need to know is called the 5-number summary. And that's just a way of listing each of these sections in order as we go across our box plot. So you can see there we have lower extreme, quartile 1, median, quartile 3, and the upper extreme. Now for this box plot, we would represent that as this list of numbers. So the lower is the 20, then we get 31, we get 50, 77, and 100. And so we have this here is called our 5-number summary. Make sure you've written that down and you know what that is, because you will need to refer back to it and be making 5-number summaries yourself. So if we have the 5-number summary, we can then go and turn that into a box plot. If we're given the numbers 13, 24, 43, 71, and 93, we go along, we just put a line at each of these sections. And then our middle 3, we put our lines through, and then we have a line through the whole way. So hopefully that's self-explanatory. If you do have a question about how we actually construct it from the 5-number summary, let me know. Often we'll be given data and you need to find the 5-number summary. So lowest data, quartile 1, median, quartile 3, and highest data. And then you can turn it into your box plot. But you're going to need to do that process, and we're going to practice that. Here we have 3 different box plots, and you can see their 5-number summaries correspond to those. So if you want to have a bit more of a look at them, you can pause the video. I'm going to move on. Finally, box plots are really helpful for allowing us to look at the skew of our data. So remember, when our data is skewed, say our data looks like this, our data is going to be positively skewed. If it looks like this, it's going to be negatively skewed because we're looking at the tail, and that's what tells us. Otherwise, you could have data running out of space that's symmetrical, so it's the same on both sides. So in our box plots, what's really going on is if we take the median, we've got 50% on each side. So here we have 50%. Sorry, that looks horrible. And then here we have 50% again. Now within that, we found the quartiles, which is breaking it into another half. So we would have here is 25. Maybe I'll do a different color. Sort of different color. 25, we'd have another 25, 25, and 25. So we can see that 25% of our data is between these two numbers, 25% these two, then again between these two, and again between these. So we can look at it and sort of make in our heads what those pictures look like. So for this one, if we rub out all that I've drawn there, you can look at a box plot and not only get the interquartile range and the range very easily, but you can see that this part here is very close together compared to this section. So we're going to have more values here, so our data is going to be more up. It goes up, and then we have a bit of a slower fall. So our data is reasonably symmetric, but if anything, it is going to be positively skewed. Our next one, again, we have most of our data is over this middle part. Sorry, that doesn't look right. So we go up, our center is there, and then we go down. So wherever our center is, that's going to be the peak of our data. And then we should have about the halfway point going up. So data should probably look more like this. But hopefully you get the idea of what our skew of data looks like. So that one would be positively skewed. In the next one, we're going to have our data start here. It's going to be 50% here, 100% up here, 50%, and then down. So our data comes, it's very much bunched in the middle. It's going to look something like that. So you could probably say that that is negatively skewed. So we are going to have another activity to look at the skew of data, but I just wanted to quickly talk to you about those equal 25% sections. And what that means is that 25% of our pieces of data are there, 25% are here, 25 here, and 25 here. Okay, if you have any questions, please bring them to me. Otherwise, continue with the work that's on Canvas. Thank you.